Okay, good morning, Akshat Kapoor. I welcome you for another important chapter, which is in your course student mass relationships in chemical equations. We have discussed with you chemical reactions, chemical equations. ठीक है? We told you what we have told you, just a recap of what we have done, students, with you. I told you, students, chemical equations. Chemical equations. ठीक है? We have done it. We told you
Yeah.
reactants are reacting to form a product, and we are able to write what we are able to write, students, the chemical reaction, chemical equation. And in the chemical equation, what we said, to give complete information, we should mention the physical state of the reactants and the products. For example, students, for example, I'm saying, for example, student, here is a reaction. We are saying an automobile airbag is inflated with nitrogen produced from decomposition of sodium azide. Sodium azide, the formula of sodium azide is, students, NaN3. What is NaN3? Sodium azide. Now, here I will solve this question later on. First, I am trying to tell you that NaN3, what is NaN3, students? This is a compound which is called sodium azide. Sodium azide. You have seen, I have mentioned solid here. I have mentioned solid here. And what on decomposition, students, what is happening? This compound NaN3 is a solid. On decomposition, it decomposes. I told you about the types of the reaction, student, in which I said decomposition reaction. What is a decomposition reaction? One substance decomposes to give two or more products. This is example of that. Sodium S, nitrogen gas. This is the solid, this is gas. But is this reaction balanced, students? Tell me, is it balanced?
No, it's not.
One sodium, three nitrogen, two nitrogen. It is not balanced. So you are saying, student, this is not balanced reaction. And we told you the law of conservation of mass, which says reaction must be balanced. That means the number of atoms of the reactants must be equal to number of atoms of the products. Yes or no?
Yeah.
Okay. Yeah. So we have to balance it. Before we do anything, we have to balance the reaction, students. And how to balance, we have told you. How to balance the reaction, students. I said ki what was the trick in balancing by hit and trial method? Do you remember what trick I told you, students? What trick? Which
Uh,
compound?
start
Uh-huh.
start with the one with the most atoms.
Yes, correct answer. That's so good of you that you have in your mind, students. I am so glad that you understand what I said. This molecule has maximum number of atoms. See that? It has how many? Three nitrogen atoms, one sodium atom, and therefore I will use it. The story is there are three nitrogen, student, here. How many? Three. Here two. Here three. So if I have three, if I make it three students, because I want a whole number, I can make it 3 by 2. If you want, make it 3 by 2. Supposing I make it 3 by 2. Then what happens? 3, this is 3 by 2 into 2. 3 by 2 into 2, how much? 3. Okay? Does it balance the number of nitrogen atoms on both sides? Tell me. 3 by 2 into 2, how many? 3. And there are 3
Yeah.
nitrogen. Sodium 1, sodium 1. But when we write a reaction, we don't write fractions. So what I will do, I will multiply the entire equation by 2. So that 2 into 2 becomes 3. What will be the answer then, students? Multiply the entire equation by 2 to remove the fraction, to remove this fraction 2. The result will be, students, 2NaN3S produces 2NaS, and multiply 3 by 2 into 2, it becomes 3N2 gas. Now, this equation is balanced, students. Tell me, is it balanced? How many atoms of sodium? 2.
Yes.
2.
Two.
Nitrogen, 2 into 3, 6. 3 into 2, 6 atoms. Yes, we have balanced the reaction. And I am thankful, student, you helped me in balancing the reaction. This is what I mean to say, that when I say this is my reaction, what it means to us students. What it means in terms of, now we are interested to talk in terms of masses, molecules, moles. All you are telling to me that molecules of this, two molecules of this decompose to give 2 atoms of sodium and 3 molecules of nitrogen. That is what it is telling me, that 2 molecules, because it is not an atom, it is a molecule. 2 molecules of NaN3 produces 2, these are atoms of sodium, atoms of Na, and 3 molecules of N2 gas. ठीक है? 3 molecules of N2. Is that what it means? Tell me. Two of this produces 2 of this and 3 of this. Right or wrong? This is
Yeah.
a
Right.
balanced reaction. Only in a
Yeah.
balanced reaction I can say that, students, the reaction must be balanced. This is what we call as a stoichiometry of a reaction. This is what I'm trying to tell you. This is a stoichiometry of the reaction, students. Stoichiometry means I must balance the reaction. And then I say, okay, this two of this means 2 molecules of this produces 2 particles of sodium, 2 atoms of sodium, and 3 molecules of nitrogen gas, students, and 3 molecules of nitrogen gas. So this is what we call as, every reaction has a stoichiometry. The reaction must proceed in definite proportion, and we must be able to write the balanced reaction. That is why we learn, students, how to balance a chemical reaction. Now, if I want to find out about the masses of these, students, how will I find the masses? When you do a reaction in industries or anywhere, you say, okay, I take 50 grams of substance A, react with 60 grams of substance C to form, supposing, some product. Now I am talking of relationship between these molecules and masses, student. You know that atoms have mass. Atoms have mass. Yes or no? Different atoms have different masses. And
Yeah.
mass is coming from where? We are now talking of the masses relationship, students. What is the relationship between molecule and masses? And we know, students, that different atoms, students, different atoms have different mass. Yes or no?
Yeah.
If I say hydrogen, you say carbon. The mass of carbon is not same as mass of hydrogen. The mass of oxygen is not same as hydrogen. Mass of nitrogen is not same of hydrogen. In this case, if I say mass of sodium is not equal to mass of nitrogen. They are different masses. They are different masses. And if I say N2 is not N, so the mass will be different. Now the question is, how do we find the relationship between masses? Before that, we should must know what is an atomic mass. You are saying atoms have got atomic mass, student. In other words, students, you will agree every atom has a mass. Tell me, every particle has a mass? Yes or no?
Yeah.
Okay.
Yeah.
Now the question is how much mass atom has? Your mass is, student, 60 kg. Your mass is 60 kg supposing. Now the question is, atom is very, very small. Atom is very, very small. Mass of atom is very, very small. Then how will I measure the mass of the atom? That is the problem, student. So now I'm talking of atomic mass. Now I am talking, we have learned how to balance the equation. But you are saying, sir, give me how many grams of this reacts to produce this, how many grams will be produced. You are saying now, supposing I have 80, here she says, supposing you have, you want to produce 87.5 grams of the nitrogen, student, then how much I should take this? That means I must know the atomic masses. Then only I can do any calculation or stoichiometry calculation. Now we are interested to understand, student, what I am trying to say, what I am trying to come to the point, student. Atomic mass. Now I am talking of what is atomic mass. Now this is a real problem because you know mass of atom is very, very small, student. Mass of atom is very, very small. So how will we measure it? How do you measure your weight? Or you stand on a weighing machine, it gives you.
Mm.
But where is the weighing machine for the atom? Atoms are very, very small particles. And you are saying the if size of the atom, if you see the radius or diameter of the atom, you are saying the dimensions of the atom, you said, are of the order of 10 minus 10 meter. This, if I say this is the radius of the atom, student, this is very, very small.
Yeah.
Size of the atom
Very
is
small.
very, very small. These are very, very small particles, students. Then how will we measure the mass? That was a real problem, student, for them. And before 19th century, it was very difficult. So when we cannot determine anything exactly, what we do, we talk of relative atomic masses, student. Relative atomic masses. What do you mean by relative atomic masses, student? I compare mass of one unit with others. I assume, I consider, okay, in a class there are 50 students and I take one student as my standard reference point, and compare the heights of the other students. Okay, this is taller than this by this factor, and this is less taller than this student by this factor. So we do a relative scale, student, relative to, we are saying, okay, relative to hydrogen, how much heavier is oxygen? We are saying, okay, relative to hydrogen, how much heavier is sodium? So they started doing that, student, by studying the chemical reactions. By studying the chemical reactions. What we are saying, mass of atom and subatomic particles are so small, so they have to form some scale student to measure or to compare the atomic masses of these elements. There is a history of this which I do not want to go in this lecture, that how they got it. But important point to note is that students, the mass of atom is very very small, and in 1961 students, it was decided that carbon isotope C12, this is a carbon, the carbon 12 is a stable isotope of carbon. Carbon has got isotopes. This is a stable isotope of carbon, and this was chosen as a reference point for comparing the atomic masses of other elements. This was used as a reference for comparing the atomic masses of this element. Today we have machines, student instruments which can measure the mass of an atom exactly. That is mass spectrometer. It is possible to measure the mass of the atom by using mass spectrometer, students. We have today mass spectrometer by which we can measure the mass of one atom, which is very, very small. So the story is that mass of one atom is very, very small. And how do we make atomic mass unit, student? So as I said, the carbon 12 was chosen, and relative to carbon 12, the atomic masses of other atoms were found out or given. What we are trying to say, student, to make the point more clear, I am saying the atomic mass in 1961, carbon 12 isotope was chosen as the standard reference for measuring the atomic masses. One atomic mass is equal to one atomic mass unit. They said one atomic mass unit, I can represent 1 AMU. Nowadays they represent it as 1U. So 1U or 1 AMU, one atomic mass unit, is defined as exactly equal to 1/12 student, the mass of one atom of carbon. One atom of carbon 12. So what is atomic mass unit then? What this question is asked many times to the student. What is atomic mass unit? This is question is asked many times to the student. So our answer is one atomic mass unit or one AMU or one U is 1/12 mass of one atom of carbon 12. And you know, mass of one carbon atom 12 has been determined by mass spectrometer. What I said, by mass spectrometer, we can find the mass of carbon 12. And if I divide that by 1/12, it comes out to be around this value. That means, student, you can see 1 AMU is equal to 1 AMU or 1 unit is equal to how much? 1.66 10 minus 24 grams, students. Tell me how small is this value? Very small. The mass of one unit is very small, students. And the this we call as 1U. And I say the mass of carbon is 12U. Mass of one atom of carbon, I am saying. One atom of carbon. ठीक है? Is how much? 12U, students. What it means? What is the value of U? 1.6, or in other words, you are saying it is 12 into 1.66 into 10 minus 24 grams, student. What is this? This is the mass of one atom of carbon. ठीक है? This is the mass of one atom of carbon, students. And if I say mass of hydrogen atom, student, mass of one hydrogen atom. Hydrogen, as you will see in the periodic table, mass number is given as 1. That means hydrogen has one proton, student, and one electron. So mass of hydrogen atom is 1 into 1.6x into 10 minus 24 gram, or I can say mass of hydrogen, student, is 1 AMU or 1 U. ठीक है? If I say mass of one sodium atom, it is 23 U. That means 1 U is how much? 1.6 into 10 minus 24 grams. And I'm saying it is 23 U. When I write U, student, it means 23 times that unit. 23 times that unit. What unit is that? 1.66 into 10 minus 24 gram, which is my reference carbon 12 isotope. On that, relative to that, we are giving the atomic masses. So you sometimes they will call you, these are called relative atomic masses. Why we call them relative atomic masses, students? Why we call them relative atomic masses? Because we are comparing the mass of all the atoms with which element? Tell me, which element is standard? Carbon 12.
Carbon 12.
This was decided by, there is an International Union of Applied and Chemistry, IUPAC, students. These scientists together decide certain rules or conventions in science or in chemistry. So they decided that carbon 12 is a very stable isotope. The mass was determined by mass spectrometer, and because carbon has got 6 protons and 6 neutrons, so the mass will be, what we are trying to tell you, if I take carbon, student, it is written like this. Carbon has 6 protons, 6 neutrons and 6 electrons. So the mass of carbon atom will be sum of the mass of 6 into mass of neutron and 6 into mass of electron. But this is negligible because the mass of electron is very, very small. So we say 6 plus 6, 10, 12 units. 12 unit means what? There are mass of proton is almost equal to mass of the neutron. So you are saying it is 12 mass units. And one mass unit is how much? 1.6 into 10 minus 24 grams, students. And sometimes you will see that in the table which is given in the book, these masses are coming in fractions. Masses have been listed in fractions, student. For example, for chlorine, they say 35.5 U. Now, why there is a fraction, student? These are not the mass of one atom. These are called average atomic masses. What we are saying? Average atomic masses. Why do we take average atomic masses, students? Can you tell me why do we need average atomic masses?
Because that's like the mean of all three. Like, what's the closest?
Why do we take mean? Because student, atoms have got, in our nature, in natural abundance, atoms have got isotopes, students. What are isotopes? These are atoms which have the same atomic number. Atoms which have the same atomic number but different mass number. because number of protons is same, but number of neutrons becomes different. For example, Cl has got chlorine has two isotopes, which we write like this. Chlorine has two isotopes, students. These are the two isotopes of chlorine. In nature, if we see chlorine, there will be two isotopes, students. And one of this is 75% in abundance and other is 25% abundance. Now, what mass I will write for Cl then? Atomic number same mean element is same, but number of neutrons becomes different. Number of protons is the atomic number which is same, but number of neutrons is different, students. So in this case, we have to find the average. How do we find the average? 75% you are saying is this one, and 25% is which one? 37. So then I have to find this average. So this comes out to be 35.5, students. So you can understand now the meaning of why there are fractional atomic masses in the book. Tell me any doubt up to now.
No, good.
Okay. Therefore, students, the atomic masses are very, very small. And if I want any relationship between mass, as I told you, for any reaction, I will find these masses are extremely small, of the order of 10 minus 24 gram, students, which we don't deal in our everyday life. Do I deal with such number in everyday life? Tell me. How will I measure 10 minus 24 gram? No. So what will we do? Your mass is 60 kg. You can measure by machine. You can measure 1 kilogram. You can measure zero point 0.1. You can measure 1 gram. You can measure milligrams. Milligrams in jewelers are measuring in milli or micrograms. But what about 10 minus 24 grams, student? We can't measure in
No.
our everyday life. We don't have any balance for that. So when I'm doing reactions, I don't talk in terms of students 10 minus 24 gram. I don't tell you that okay, take student one 10 minus 24 gram of sodium. Where you will get it? Nothing. We don't have anything. So this problem is there. So what will we do? What the scientists were doing? What they decided, student, that what is the important point in this, student? As we said, now we are aware of atomic masses. And you are saying mass of one atom of carbon is 12U. ठीक है? Mass of one atom of sodium is 23U. Mass of one atom of hydrogen is 1U. Supposing. This I have taken whole numbers. There could be some fractional values also. For example, for mass of Cl, you are saying is 35.5U. This is mass of one atom. Okay? Now the problem is, student, 1U. What is 1U? Mass of nitrogen, you are saying is 14U. Or AMU, you are writing U. That U means one atom. Now the student, what is 1U? 1U is how much? You have just found the value of that. How much is the value? What was the value of 1U? 1.66, 10 minus 24 gram. 1U is 1.66, 10 minus 24 gram, students. What is the meaning of this? What calculations I will do, student? Very difficult. In order to solve this problem, student, a mole concept has been given. Mole concept. What is a mole, student? Mole is only a number which was given by Avogadro. You have seen this is the name of Avogadro. He says that 1 mole is equal to 6.022 into 10 power 23. What we are saying, student, we are defining a number. 1 mole is equal to 6.022 10 power 23. This could be atoms, particles, molecules, or ions, anything, or molecules or ions. Supposing I say these are 20 apples. I haven't mentioned the name 20 apples. Now I say there is 1 mole of apple. 1 mole will mean how many? 6.022 10 power 23 apples. See how big is this number? This was experimentally determined, student. Experimentally determined that mass of 1 mole of carbon is equal to 12 grams. 12 grams. What is 1 mole of carbon? How many? There are 6.022 into 10 power 23 atoms of carbon, students. They will weigh how much? 12 grams. How much? 12 grams. That means, students, 12 gram is a number which I can deal with in my everyday life. Tell me, can you deal 12 grams or not? If I said mass of one atom of carbon is 12 U, this U is how much? 12 into 1.66 into 10 minus 24 grams, student. This number is very small, but this number I can use in my everyday life. Tell me, yes or no? This is a small number, but this
Um,
12 gram is a good number for me for calculations,
yeah.
because this is the mass of one atom, this is the mass of 1 mole, 1 mole of carbon. In other words, student, 1 mole of carbon can be written as 12 grams, and one atom of carbon, we are saying the mass is 12 U. And this is why the mole concept was given, student. You can see it is represented by N0, Avogadro's number. It is called Avogadro's number because was given by Amedeo Avogadro. In other words, students, I am making the things very simple for me. This was determined that if there are 6.022 10 power 23 atoms of carbon, their mass comes to be 12 grams, students. Similarly, for other atoms also, we can convert U into grams. You are saying sodium, one atom, mass is 23 U, students. And if I say mass of 1 mole of sodium, student, this will come 23 grams. You can take anyone. Any, you are saying nitrogen, the mass of one atom of nitrogen is 14 U. Now, if I take 1 mole of nitrogen, the mass will be 14 grams. Therefore, student, it becomes easy for us that the quantities which we are defining now, which will be given in your book, students, they are called grams per mole. We give them grams per mole, student. Gram per mole means that here we are talking of the mass of 1 mole of the element, molecule, or the substance. Therefore, the mass of 1 mole of a substance is equal to relative atomic or molecular mass in grams. The atomic mass of element gives us the mass of one atom. To get the mass of 1 mole of atom, molar mass, we have to take some universal value but change the U to G. Molar mass of atom is also known as gram atomic mass. So whenever I will write U, it will mean mass of one atom or one molecule. But when I will write grams, it means the mass of 1 mole. And how many particles will be there in 1 mole, students? 6.02 into 10 power 23. This is also called Avogadro's number. Clear?
Yeah, got it.
So Avogadro number sometimes represented like this, is a collection of how many particles? So many particles. For example, you say H2O 1 mole. That means it will have 6.022 into 10 power 23 molecules of H2O, students. Mass of one molecule is very, very small, but this mass will be coming in grams. Coming in grams, students. That is why we have chosen moles for our calculations. That is the idea of mole concept. In the stoichiometry of the reaction, students, in the stoichiometry of the reaction, which I was talking with you now, what I am trying to explain to you, students. For example, in this case, student, what I can say that you said when I balanced this reaction, what was the balanced reaction? 2NaN3 student, ठीक है, produces 2Na plus 3N2 gas. This is my balanced equation, students, as I did it here. So according to the mole concept, I can say that 2 moles of this compound, when they decompose, they will produce how much? 2 moles of sodium, 2 mole sodium, and they will produce how much? 3 mole of N2. This is the stoichiometry of the reaction now. I am talking in terms of moles, student. 2 moles of NaN3 student decompose to give 2 mole of sodium and 3 moles of nitrogen. This is my balanced equation. And we know what 1 mole is. How many particles will be there? How many molecules will be there? 2 moles will contain how much? 2 into 6.023 into 10 power 23 molecules of this. And this will be how many atoms? 2 into 6.023 into 10 power 23 atoms of sodium. 3 into 6.023 into 10 power 23 molecules of nitrogen gas, students. So we can use moles now. And we know when I use mole, student, then I can use the atomic masses in grams. Atomic masses in grams. Clear? Any doubt?
No, not at all.
Okay. So I will proceed further. Now we know what is atomic mass. Now we know what is mole, student. What is mole? Okay. Further things. Interesting. Very important points. Now we are saying molecular mass and mole concept. Why you defined atomic mass? Now we are saying atomic mass is the mass of atom. But you have but atoms combine to form molecules. You have molecules, student. You have compounds. So how will we find the, if you have molecule, for example, student, if I have molecule H2O, how will I find the molecular mass of this? Molecular mass means sum of the atomic masses which are present in a molecule. So if I do the sum of atomic masses, students, sum of the atomic masses of elements, then I will get the molecular mass. For example, I say find the molecular mass of water. What is the, you are saying atomic mass of hydrogen is how much? Hydrogen, you are saying 1U. Oxygen atomic mass, we know 16U for one atom. This is the mass of one atom. So if I have to calculate the molecular mass, then how will I do it, students? How many hydrogens are there here? 2. 2 into 1 plus how many oxygen is 1? 1 into 16. So what is the coming, students? 2 plus 16? 18U. That means, student, mass of one molecule of H2O is 18 joule. If I say mass of 1 mole of H2O, student, that will be 18 grams. 18 grams. This is called the molecular mass, students. And in the book, they have given the values of molar. This is also called molar mass. Molar mass. Molar means it is given in terms of grams per mole, students. Per mole, gram per mole. We write G per mole. This is called gram per mole. Gram per mole, student. Therefore, student, supposing you have a cup here. In this cup, you have, supposing, 18 grams of water. How much? 18 gram of H2O. 18 gram of H2O will be how many moles, student? 18 gram of H2O is equal to 1 mole of H2O, students. And 1 mole mean how many molecules will be there? 6.022 into 10 power 23 molecules of H2O, students. Interesting? You are drinking water. You take water in a glass, and you know how many molecules are there? Millions of molecules. You are just drinking 18 grams of water. That will contain 6 into 10 power 23 molecules of H2O. Very, very small molecules of H2O. They are very tiny, very small. You can't see one molecule, but you can see collection of molecules. Water you can see. You are taking bath with water, and what you have? Not one molecule. You cannot take a bath with one molecule of water, student. One molecule of water is very, very small. What you have is millions of molecules of water. And they are forming liquid. They are forming liquid, student. Got the point? That, students, here you have water, student. Water, there are very, very tiny particles. How many? How many? Tell me, how many? You can't see them with the eyes. Millions. And that's what you are drinking. You are not drinking one molecule. You are not taking a bath with one molecule, student. It's not possible. And that is why we talk of forces, attractive forces. We talked of attractive forces in one of the lecture. We talked of how much attractive forces they are. They are forming hydrogen bond, and they become liquid. Got it?
Yeah.
That is why, students, now we are talking of molecular masses, grams per mole. Molar mass. So, for example, calculate the molecular mass of HNO3, students. How will we calculate the mass of HNO3? HNO3, student. I say calculate the molar mass, students. I give you 1 minute for this answer. Hydrogen atomic mass, I am saying, is 1 gram per mole. Now I'm using gram per mole. Nitrogen, I'm saying, is 14 gram per mole. And oxygen, I'm saying, is 16 gram per mole. Can you tell me what will be the molecular mass of HNO3? HNO3 is my nitric acid, students, nitric acid. So you have 1 minute to answer the question, students. Interesting. Well, chemistry is very interesting. You will love it. And you will
Yeah.
become chemistry. I'll teach you everything. Don't worry. You will be with me. You will see how good you are in chemistry. Can you find the molecular mass of HNO3, student? Atomic mass we are giving in molar masses, gram per mole, gram per mole. Oxygen 16, nitrogen 14, hydrogen 1. What will be the answer?
So it will be
1
1
plus
plus
nitrogen is
14
14 into 1.
plus
Oxygen is how much?
16.
Into.
16 times 3. Yep.
So, what is the final answer coming, student?
15. Let me get my calculator.
1 plus 14 plus 48. So, you have a calculator, student, you can do it. HNO3 molecular mass, HNO3. So 48 plus 50.
63.
Okay, 63 is the correct answer. Then what you write is gram per mole. If I write 63 U student, then it is the mass of one molecule. One molecule mass is 63 U and one mole. When I use one mole, then I write gram per mole, 63 gram per mole. So there are 63 grams in one mole of HNO3. In other words, students, if I say if I say carbon dioxide gas, then what it means 12 plus 16 into 2, you have 44 grams per mole, students. One mole of CO2, one mole of CO2, the mass will be 44 grams. One mole of CO2, the mass will be 44 grams, student. Now, supposing there are certain compounds, student, which are ionic compounds. Ionic compounds. For example, NaCl. The NaCl which you are eating, student, salt, sodium chloride is a salt student which you are using at home. This is an ionic compound. Ionic means there will be one sodium and it will attract many chloride ions. And one chloride ion will attract many sodium ions because they are ionic. They have charges. Opposite charges will attract. And in that cases, we will find the formula unit mass, which we will add the atomic mass of sodium and chlorine to find this value. For example, for NaCl student, if I have to find the mass of NaCl, sodium is 23.1 and chlorine is 35.5. So it becomes 58.5 U. 58.5 U is the mass of one molecule of NaCl. And if I say one mole of NaCl, that will become 58.5 grams. ठीक है? Clear? Is it clear?
Yeah. Yeah. Yeah.
If I say calculate the formula unit mass of CaCl2, now if I have to find for CaCl2 student, then we know calcium is 40 and 2 into 35.5. Cl is 35.5. So this will be the mass, formula unit mass of CaCl2 students, which we can calculate 40 plus 71. So what it will be? 111 gram per mole. 111 gram per mole. Student, this is 111 gram per mole for CaCl2. So this way, student, now we are in a position to find the, we are in a position, students, to find the molecular masses. Therefore, we defined atomic mass, we defined molecular mass. By adding the atomic masses, we can find the molecular masses, and we defined the mole. Clear? Any doubt in this? Do
No,
we
not
have
at all.
doubt in this? Tell me.
No, not at all. No.
Okay,
Good.
no doubt. Very good, very good. Very quite intelligent student, quite intelligent. Okay. Now let me come to a point here, too. What he is saying, students, what he is saying here, that in this reaction, for example, now this stoichiometric question, relationship between mass and grams, moles, and Avogadro's number. This is very important now for solving the questions. This is important, student, for solving the question. So let me make some space so that I can explain to you very interesting thing now. I hope you have taken these notes or you will get a video recorded. In case of doubt, you can listen to the video and see. You are already being listened by large number of people all over the world. You and me, one day I will take your picture also so that it is in the YouTube. ठीक है?
Yeah, got
Okay.
it.
We both will be talking and interacting. Then a lot of students are asking me, sir, who is this student who is studying chemistry? We want to see him. Okay, I said okay. So we are together. Every life is a journey, student. You know, we meet so many people. And in our life, sometimes we meet good people and they become a part of our family and friends. Students, they become a part of the family and friend. My students are my family. So you are a part of my family now. You are very close to me. You can call me anytime. You can talk with me. You can, students, ask me questions and doubts, no problem, no issue. And you can share these videos with your friends and they are interested to join with us, they can, no problem. So students, what we are saying, our purpose is to teach more and more students so that they learn chemistry in a very better way, in a simple way. Student, I want to teach you in a very simple way, simplest way. Now you are saying that what we have learned, atomic mass. Then you learned, student, molecular masses. You learned, student, mole concept. One mole is equal to 6.022 into 10 power 23 particles, atoms, molecule, anything. I say one mole of the students. One mole of student will be how many? 6.02 10 power 23. It is a number. It is a number. That's all. And then we told you about AMU or 1 unit. 1 unit was very, very small. What was the value of 1 unit? Students, very, very small value in terms of grams. Then we learned what we say molar mass, which is represented in terms of gram per mole. The mass of 1 mole, the mass of 1 mole, students. So if I say n moles, students, how do we calculate n moles, moles of a substance? If I have W gram of a substance, of anything, if I have W grams of a molecule, student, or a substance, if M is the molar mass, M is the molar mass is means gram per mole, student. Then how will I calculate the mass? W by M. This is my formula now. N is equal to W by M. What is W? Mass of the molecule or mass of the substance, molecule or atom, divided by the molar mass. Molar mass. So if I have to calculate the moles, student, I have to divide by mass divided by molar mass. If I mass is in grams, then this is in gram per mole, which means equal to mole. Got it? So if I am given grams, you are saying, I am saying, okay, 28 gram of nitrogen, 28 gram of nitrogen, students. Then how many moles? How many moles will be there? What is the molar mass of N2? 14 into 2, 28 gram per mole. So I will divide, this is M, W by M. W is how much? 28 gram is given to me. And this value is 28 gram per mole, students. So this N equal to 1 mole. Therefore, we can now calculate mole and grams. This is a relationship between mole, student, and mass and molar mass. Got the relationship? Relationship between, I am saying moles is equal to student grams of the substance divided by molar mass of the substance, which we represent by m. N is equal to W by m. So this is my formula. Clear? I am going to use this formula for converting moles into grams. Grams will be mole into molar mass, and moles will be gram by molar mass. Important formula which I will use. And we already know when I have, if I have 1 mole, that is 6.023 into 10 power 23 atoms or particles or whatever molecules, etc. Okay? This formula is known to us now. Any doubt?
No.
Okay. You can note down this formula, student. This is important. And in any reaction, student, what will we do, student? In any reaction, what will we do? What we will do in any reaction, student? देखो, for example, I will always convert first moles, then moles into grams. First, I will convert everything into moles, then I will convert moles into grams, student, because it is will help me in solving the question, student question. Okay. Now this question is before us on the screen, students. It's from question which you sent me in the mail, students. Now, how will we do this question, students? He is saying an automobile airbag is inflated with nitrogen produced from decomposition of sodium azide. You know, in the cars, they have now safety balloons that contain sodium azide. If accident takes place, the balloons are inflated because nitrogen gas is released. This nitrogen gas is released, students, and balloons get inflated. They save the driver. This is a safety device which is used now in the cars. Safety balloons. Chemistry is used everywhere. Interesting. That nitrogen gas will fill up the balloon and that balloon will come in front of you. So accident you will be saved. And this is a reaction NaN3 Na. The mass of nitrogen in fully air is 87.5 gram. This nitrogen is, student, 87.5 gram. What mass of sodium azide is required? You need to find what mass of this is required to produce 87.5 gram. The mass of nitrogen in inflated is 80. What mass of sodium azide is required to produce this mass of nitrogen? So now we are talking of calculations of stoichiometry, students. We have to learn. This is a difficult part and we have to learn. But I said, I will first balance the reaction. First step, students, balance the reaction. Okay? You can balance the reaction? Tell me yes or no. I have balanced it. And I say, according to this, the moles, 2 mole of this will produce 2 mole of this and 3 moles of nitrogen. I'm saying 2 mole of sodium azide, student, will produce 2 mole of sodium and 3 moles of nitrogen. Clear? Can you see that mole?
Yep.
I always convert in moles. Now I can convert them into grams, student. What is the formula? You have said N is equal to W by M. So grams is equal to N into M. So if I multiply 3 into what is the molecular mass of nitrogen? N2. N2 will be 14 into 2, 28 grams, student. 3 into 28 gram. And what will be sodium? There are 2 sodium. 2 Na. What is the atomic mass of sodium? Molar mass of sodium is 23 gram per mole, student. So 2 into 23. And what is sodium azide? I have to calculate. NaN3, student. How much it will be? 23 for sodium and 3 nitrogens. How much is nitrogen? 14. 14 3 is 42. So how much it will come, student? 565. ठीक है? 565. Am I right? So what is sodium azide? One sodium is 23, one nitrogen is 14, 14 into 3, 42. That is 65, and there are two of this. So 2 into 65 grams. Now, this is the story that so many grams of sodium azide will produce how much of nitrogen? So many grams. God can see that. In other words, students, I am saying what I am saying here, 2 into 65 gram of NaN3 student will produce how much? Will produce how many grams? 3 into 28 gram of nitrogen. ठीक है? Is this relationship clear?
Yeah,
I am
got it.
converting moles into grams, or I can convert grams into moles. The formula I gave you, this one, you can use. I said this formula is, I will be using this formula, students. Now he says, what mass of sodium azide is required to produce 87.5 gram of nitrogen? Now again, unitary method, unitary method. You are saying 3 into 28 gram of nitrogen needs 2 into 65 gram of NaN3. One unit will need how much? 2 into 65 divided by 3 into 28. And how much you want? 87.5 gram of nitrogen. Will need how much, students? This is a unitary method calculation, that's all. 3 into 28 into 87.5 gram of NaN3. Now this calculation we have to do. You have a calculator, student, you can do it. By this method, student, we can find out, student, what we can find out? That we can convert mass into moles and moles into mass. Okay? This is the first part of what we are doing. We learned to find the atomic mass, molecular mass, then moles, Avogadro's number, and the relationship between students. What relationship we have found out? Mole, mass, and molar mass. And this calculation you can easily do with the calculator and find out, student, how much mass will be required. Tell me, any doubt?
No, good.
It's very interesting, but we have to practice. You can see that a lot of practice is required, because now we are coming to the stoichiometry part of the reaction. Student, here calculations will be involved. In the industries, they have to do the calculation that how much substance you have to produce. If you are producing ammonia, for example, you are manufacturing ammonia in the industry, which is used in fertilizers. Then they will say how much ammonia you want. Oh, you want a large amount of ammonia, then you will give quantity. Then according to that, we will set up the reaction, and we will mix nitrogen and hydrogen gas to form ammonia. Then we can make a calculation by stoichiometry that how many moles of nitrogen will react with how many moles of hydrogen in a balanced reaction to produce amount of ammonia. Then I can convert them into grams, students, and therefore I can prepare the products which I want. So it is a great application. In every reaction, we will need to know. So we will have to balance every reaction, stoichiometry. Then I can write moles. We are using moles. Why? Because the mass of the molecule and atom is very, very small, students. When I talk of moles, they come in grams. They come in grams, students, which can be used in everyday life. I cannot measure 10 minus 24 grams, student. Therefore, I'm not talking of molecules. I'm talking of moles. So we are using moles in chemistry. We're not talking of one molecule. One molecule is very small. I'm saying you are taking water, 18 grams with 1 mole of water. Now, you are not drinking one molecule of water, student. These are 6.02, 10, about 23 molecules of water, which are going inside your body. See, these particles are so small. You take small snack, so many molecules are there, millions of molecules. And what you are basically, you are made up of trillions and trillions of atoms, students, particles. See,
Mhm.
that
Yeah.
coronavirus you are saying, it is very tiny and so many, they grow in large number, students, large number, and they pass on from one person to another. These are all science. These particles we can't see them. Can you see coronavirus? You
No.
can't see it with your eyes. It is so small, students, and they grow in millions of things. These particles. Oh, see, everything is made up of atoms and molecules, and that's why we
Mhm.
whole concept, students. I hope you enjoyed the session, and
Yeah, but
yes.
yes, it was great. I,
Okay, we are both together.
I,
We enjoy. I enjoy the session with you. We are lively and interacting, and we are not dead people. So thank you very much. Then this lecture is finished. I will see you in my next class and continue
right.
more about it on limiting reagent and chemical equations. I thank you for having interacted and answering many questions intelligently. Okay,
Right.
bye bye. We'll see you.
Thank you. Have a good day.
Okay, have a good sleep, and I will have a good time because my classes are starting. I have many five more classes today to take. Okay, bye bye.
Bye.
I recommend me to your friends, students, so they can interact with me, join with me. Okay, thank you.